let's start our studio, and here I will discuss various means, factorial and GCD LCM programming. Here we will discuss three different type of means. First one is arithmetic mean or AM, second one is geometric mean or GM, and third one is harmonic mean or HM. Suppose we have a data x1, x2 up to xn of length n, then arithmetic mean is defined as 1 by n summation xi I equal to 1 to n. Geometric mean is defined as x1 into x2 into xn whole power 1 by n. And harmonic mean is defined as n by 1 by x1 plus 1 by x2 up to 1 by xn. Again, for a frequency data, say f1, f2 up to fn, that means x1 has frequency f1, x2 has frequency f2 up to xn has frequency fn. That means x1 occurs f1 time, x2 occurs f2 time, and so on. AM is summation xi into fi I equal to 1 to n by summation fi. Sometimes we take summation fi equal to capital N, so AM will be summation xi fi by n. Similarly, GM will be x1 power f1 into x2 power f2 up to xn power fn whole power 1 by capital N. And similarly, HM will be capital N by f1 by x1 plus f2 by x2 up to fn by xn. Now we will compute this means by using R programming. First, we will input a vector x of values, which is x1, x2 up to xn. So n equal to length of x, that is the number of elements. Now to compute AM, we will use for loop. So a equal to 0 and a equal to a plus I. That means we are calculating the sum, and ultimately we will use the formula AM equal to summation xi by n. The summation xi already calculated in the variable a, and we see that the AM is 18.27. A similar idea we can use for GM also. Here we will take g equal to 1 and using for loop g equal to g into I. So the product is already calculated in the variable g, and we easily compute the GM. A similar idea can be used for HM also. Here h equal to h plus 1 by I, and it will ultimately calculate the sum. So n by the sum is our HM. Now for the frequency data x1, x2 up to xn, corresponding frequencies are f1, f2, fn, and we will denote small n is the length of x and capital N is the sum of the frequency. So using the formula summation xi fi by n, we can easily compute the arithmetic mean. We have used for loop, but the index I here take the value 1 to n, and instead of I we have used xi here. We have used array xi and vary I in the for loop. Similar happens for total frequency n also. In the variable a we have calculated summation xi fi, and in n we have calculated summation fi. So using the formula we can find am. Using the similar idea we can find gm for frequency data. First we will initialize g and capital N, then using for loop with array form we can easily find the product xi to the power fi, and then we can find GM by using the right hand side formula. We also use the similar idea for harmonic mean or HM. So first we will initialize H and capital N, then using for loop we can easily find the harmonic mean. To compute a factorial or factorial say n without using inbuilt function, we will use for loop. The idea is for I equal to 1 to n, fact equal to fact star I. First we have to initialize fact, so fact equal to say 1. Now when I equal to 1, then fact is fact star I, so initialization, that one is I 1 into 1. That means fact equal to 1. When I equal to 2, fact equal to 1 into I equal to 2, 2. when I equal to 3, fact equal to, now our fact is 2, so 2 into 3. Again when I equal to 4, fact equal to 2 into 3, and again I into 4, and so on. So we can easily compute factorial using for loop. First we will put the value of n, say it's 7, then just using the previously discussed algorithm we can easily find factorial. Next we will discuss GCD and LCM. So first I will discuss GCD and LCM for two numbers, then we will extend it in more than two numbers. Suppose we have two numbers, say 3 and 18, and we will find its GCD, then we will take the minimum 3 and we will run a for loop I1 to 3 and check if n1, so let's say this is our n vector, that means n1 is 3 and n2 is 18. So n1, for each I we will check the remainder and we will check whether I divides the two numbers n1 and n2, that means 3 and 18 or not. If yes, then GCD equal to I. Say for I equal to 1, this is by default true, so GCD equal to 1. When I equal to 2, this is not true. That means GCD won't be updated here. Again, for I equal to 3, this is true. That means I divides both n1 and n2. So GCD equal to 3. Like this, GCD get updated. And once we find the GCD, we know the formula. This is GCD into LCM equal to product of the two numbers. That means 3 into 18. So LCM equal to 3 into 18 by GCD, that is our 3 to 18 will be the LCM. Similar ideas can be used to find the GCD or LCM for more than two numbers. Say we have three numbers, 3, 9 and 12. Then to find the GCD, we will first calculate the GCD of first two numbers. So 3 and 9, GCD will be 3, and then 12. Again, GCD of these two will be 3. Like this, we can find the GCD of more than two numbers. Suppose 3, 9, 12, 13, 3 and 9. So GCD will be 3, 12, 13. Again, these two will be 3, 13, and again, so there will be no common divisor between 3 and 13, so GCD will be 1. And like this, we can find the LCM also. Let's see. Here, the GCD is 3, so the LCM will be 9, and our vector will be 9, 12, 13. Again, the LCM of these two will be 36. As we know, the GCD is 3, so LCM will be 9 into 12 by 3. The same formula we have discussed earlier, and again 13, and again the LCM of 36 13. Similarly, 36 into 13 by 1 will be the final LCM. So let's see how we will implement this into our programming. Suppose n is our vector 3, 9, 12 and 13, and take L equal to length minus 1, that means 3. For k equal to 1 to L, again for I equal to 1 to minimum nk plus 1, if the same idea nk divides by I and nk plus 1 also divides by I, then GCD equal to I. After that, so this is the end of first loop, this is the end of this for loop. We will update nk plus 1 equal to GCD. So let's see, when k equal to 1, this is n1 and n2, and we will check the GCD by using the previous algorithm. So we will have GCD equal to 3. We are dealing with k equal to 1. We have updated our n2 into GCD, because for k equal to 2, we will deal with n2 and n3. So n2 is our GCD now. So we will deal with 12. This is for k equal to 2, and so on. We can just proceed using this idea. And for the LCM, take m equal to n. That means we are taking another vector m, and we will just update here LCM equal to the similar idea k into mk plus 1 by GCD, and we will just update mk plus 1 equal to LCM. After completion of this for loop, we will have our GCD and LCM. Now update this into our programming. Here we will find GCD and LCM of two numbers. So we input two numbers 8 and 12. Then we have just implemented the previously discussed algorithm to find the GCD. And once we find the GCD, then LCM can be easily computed by the formula GCD into LCM equal to the product of two numbers. After running the code, we can see that GCD is 4 and LCM is 24. For a different number 589 and 31, we can see that the GCD is 31 and LCM is 589. Now for more than two numbers, we have already discussed how to find GCD and LCM. Here we need an additional for loop which actually runs through the numbers. So we will check the consecutive two numbers and find the GCD and LCM and move to the next number. Like this, we can find the GCD and LCM for more than two numbers, and the code can be easily implemented like this, which we have already discussed in the theory part. With the help of vector or one-dimensional array, we can implement the code of LCM and GCD for more than two numbers. So for the given three numbers, GCD 17 and LCM 4913. Also for a different set of numbers, we can see the GCD and LCM changes. Many thanks for watching.